Hi everyone, I am Dr. B. Ashok Kumar, working as Professor of Mechanical Engineering, Nanda Engineering College, E Road. The Department of Mechanical Engineering is accredited by NBA and the college is accredited by NAC with the A+ grade. In this series of video lecture, I am going to discuss about the course Fluid Mechanics and Machinery. In this video lecture, I am going to discuss about some of the fluid properties. What is fluid? Fluids are defined as a substance that flow or deform under the action of shear force. So if we apply shear force over the fluids, it will start to flow or deform. Fluid has no definite shape of its own. On the other hand, it's conforming the shape of the container in which it is placed. For example, here the liquids are placed in different containers having different shapes. So the shape of the liquid is same as the shape of the container in which it is placed. The liquids and gases are known as fluids. Comparison between liquids and gases. Liquids have definite volume, but gases do not have. It means if we fill the water in some water or any liquid in the container, so the liquid have some definite volume. So this is the volume of the liquid in this container. So this is the volume of the liquid in this container. On the other hand, if you fill some gases in some container, the gases occupies the entire volume of the container. So the gases do not have any specific volume, but the liquid has some specific definite volume. The molecular attractive force between the liquid molecules is higher when compared with the molecular attractive force between gaseous molecules. Liquids are almost incompressible, but gases are highly compressible. It means we can able to compress the gases very easily by the application of external forces. In the case of liquid, we can able to compress the liquid to some extent only, but for that we have to apply very huge amount of forces. So normally liquids are classified as incompressible liquid. The diffusion rate of the liquid is less. The diffusion rate of gases is higher. Diffusion rate means the capability to spread from higher energy to lower energy is nothing but the diffusion. Definition of fluid mechanics. Fluid mechanics is a branch of science which deals with the behavior of the fluid when the fluid is in rest or in motion. Branches of fluid mechanics. The fluid mechanics are broadly classified into three categories. One is fluid statics, second one is fluid kinematics, third one is hydrodynamics. In fluid statics, here the fluid to be analyzed is at static condition only, that is at rest condition only. In kinematics of fluids, the fluid to be analyzed is in motion. At the same time, we are not considering about the forces or energies acting upon them. In the case of hydrodynamics, the fluid to be analyzed in motion, at the same time, the forces or energies acted upon them are also considered while make an analysis about the flowing fluid. So these are the list of fluid properties. Mass density, specific weight, specific volume, specific gravity, viscosity, surface tension, compressibility, and vapor pressure. So in this video lecture, I am going to discuss about the first 5 properties of the fluid. It is mass density, specific weight, specific volume, specific gravity, and viscosity. The first property is mass density. Mass density or just density. It is denoted by Greek letter rho. Mass density is defined as mass of the fluid possessing per unit volume of the fluid. It is denoted by the Greek letter rho. So mathematically, it is represented by mass of the fluid divided by volume of the fluid. So unit of the mass density is kilogram per meter cube. So here assume that these are the two fluids are filled in the same volume. So here the number of the fluid molecules are less per the volume. Here the number of molecules per the same volume is higher. So here the density of this fluid will be less. The density of this fluid will be relatively higher. The density or mass density of the water at 4 degrees Celsius 1000 kg per meter cube. It means the mass of 1 meter cube of volume is 1000 kg. The mass density of air at 4 degrees Celsius is 1.2 kg per meter cube. It means 1 meter cube of air at 4 degrees Celsius is just 1.2 kg only. So the density of air is very lesser than that of water. If the density of the fluid is known, we can able to find out the mass of any known liquid by using this formula. So in this case, if we know the density of any liquid, then and the mass of the fluid is also known, we can able to find out the mass of the fluid by just cross multiplying this density with the volume of the fluid. Weight, second property is weight density or specific weight is denoted by the letter small w. The specific weight is defined as weight of the fluid possessing by the unit volume of the fluid. So mathematically it is represented by specific gravity equal to weight of the fluid divided by volume of the fluid. The unit for the weight density is Newton per meter cube. Weight density can also be written in terms of mass density because the weight of the fluid can be represented by mass of the fluid by just multiplying the mass of the fluid with the acceleration due to gravity. So, but here the weight of the fluid is represented by mass of the fluid into g. Then mass of the fluid divided by volume of the fluid is nothing but mass density. So weight density equal to mass density into g. So that is W equal to this weight density equal to rho into g. So if the weight density of the fluid is known, then weight of the known volume of the liquid can be easily found out by using above formula. So if the weight density is known, then volume of the fluid is known, then we can able to find out the weight of this known volume fluid by just multiplying the specific weight to the volume of the fluid. And third property is specific volume. It is denoted by the letter small p. It is defined as the volume of the fluid occupied by a unit mass of the fluid. Mathematically, it is written as specific volume equal to volume of the fluid divided by mass of the fluid. So the unit of specific volume is meter cube per kilogram. If we rearrange this specific volume as this, that is 1 by mass of the fluid divided by volume of the fluid. So here the numerator is taken to the denominator of denominator, then it can be rearranged as 1 by mass of the fluid divided by volume of the fluid. Mass of the fluid by volume of the fluid is nothing but mass density. So the specific volume is nothing but 1 by mass density. That is, the specific volume is the reciprocal of mass density. So the unit of the specific volume is kilogram per reciprocal of mass density. So meter cube per kilogram. The next property is specific gravity. It is denoted by the letter S. The specific gravity is just comparing the two liquids. Suppose if we want to compare the liquid, means we have to compare the liquid with some standard liquid. For the standard liquid is taken as the water. If you want to compare the any gases, the standard fluid is taken as air. So the specific gravity is nothing but in terms of mass density we can compare, or in terms of weight density we can compare. So the specific gravity of any given liquid is equal to specific weight of the given fluid divided by specific weight of the standard fluid. For the liquid, the standard fluid is taken as water. For gases, the standard fluid is taken as air. It can also be written as the specific gravity equal to mass density of the given liquid divided by mass density of the standard liquid. If the specific gravity of the fluid is known, we can able to find out the density of that particular fluid. So for example, the specific gravity is known, so S equal to mass density of the given liquid divided by mass density of the standard liquid. For the water is the standard liquid. We know the value of mass density of standard liquid, that is water. So the specific gravity of the liquid is known. We can easily find out the mass density of the liquid. Once we know the mass density, we can able to find out the mass of the liquid if the volume of the liquid is known. Specific gravity of the water is 1. Specific gravity of the mercury is 13.6. What do you mean by specific? What we can understand by the value of the specific gravity of 13.6? The specific gravity is nothing but uh, relate the given liquid with the standard liquid. So as the specific gravity of the mercury is greater than 1, so that, and also it is equal to 13.6, it depicts the mercury is 13.6 times heavier than water. Then viscosity. Viscosity is defined as the property of the fluid which offers resistance to the movement of one layer of fluid layer over another adjacent fluid layer. Viscosity is simply defined as the resistance to the movement. For example, so the Newtons derived the viscosity. So for example, so this is the one fixed layer over which we are pouring some liquid. So this is the very first layer touching on the fixed flow, and this is the next layer, and then this is the next layer, and then this is the next layer of the liquid to be tend to move. So as I already mentioned, the fluid is poured on the fixed flow. So the velocity of the fixed floor is 0. So the velocity due to the coefficient of friction of this floor, the velocity of the very first layer which is touching over the floor is 0, because the floor offering the resistance to the motion of the layer. So this is the fixed layer, and this is the very first layer which is touching over the floor, and this is the second layer, and then this is the third layer. So due to the coefficient of friction of the first the floor is offering the resistance to the movement of the first layer. So the movement of first layer will be always the velocity 0, because the resistance force offered by the floor will be very high. So then this is the second layer. The second layer will be resisted by the first layer by offering the resistance. So the velocity of the second layer will be higher, will be having some value. So this is the third layer. The third layer will be resisted by the second layer, but the resistance offered by the second layer is somewhat lesser than that of the first layer over the second layer. So the velocity of the third layer will be somewhat larger than the second layer. So like that, if we move upwards, the velocity of each layer will be goes on increasing. The Newtons developed the equation to find out the dynamic viscosity. So the shear stress developed between the layers is denoted by tau, and he found that the shear stress developed between the layer is directly proportional to the difference in velocity of these two layers and the distance between these two layers. So for example, the magnitude of the shear stress developed between these two layers is equal to the ratio of the difference of these two velocities to the distance between these two velocities. So the difference between these two, the velocities of two layers is denoted by du, and the distance between these two layers is denoted by dy. So the shear stress developed between these two layers is directly proportional to du by dy. Du by dy is nothing but the rate of shear strain. This proportionality constant is nothing but the dynamic viscosity. So the dynamic viscosity is equal to the tau into 1 by du by dy. So the unit for dynamic viscosity is Newton second per meter square in SI system. In CG system, the dynamic viscosity unit is Poise. So the relation between the CG system of unit and SI system of unit is 1 phase is equal to 1